So today we will be covering 11.3, and that is solving radical equations. So we're going to solve radical equations today, and there is just a little concept that we need to go over real quick, and that is squaring both sides of the equation. So with this, that means that if two expressions are equal, then their squares are equal. So for example, if A is equal to B, then A squared is equal to B squared, and if the square root of x is equal to 3, then the square root of x squared is equal to 3 squared. So this will be a concept that we use a lot in this section, squaring both sides. So we're just going to jump right in. Actually, we need to talk about, one more thing before we get started here, extraneous solutions. So sometimes there are things that appear to be a solution but actually are not. So this is something like when you square both sides of an equation, A equals B can result in a solution of A squared is equal to B squared that is not a solution of the original equation. So that being said, when we get an answer, we must check it to verify it is true. Okay, by simply plugging it back in. To do this, we plug the answer back into the original equation. So now let's jump into some problems. So we're just going to be looking at stuff like 3 through 20. Okay, so with this one, okay, the goal here, I guess I should probably put this down. The goal is to solve the equation for the variable. So that's the first thing we need to do. Okay, to do that, we have to get the variable by itself. And then 2, we need to check for extraneous solutions. Okay, so by that, what we mean is that when we do a problem, we'll start with 4, something easy. We have 2 square root of x minus 9 is equal to 0. So you might remember Mr. Cass's Cassism, undo what's being done to it in reverse order. Okay, so we have it's being multiplied, well, the square root of x multiplied by 2 minus 9. So we need to, first of all, add the 9 over. So we're going to add 9 to both sides. So 2 square root of x is equal to 9. Now I need to divide by 2. So the square root of x is equal to 9 over 2. Now to undo the square root, I need to square both sides. So the square undoes the square root. So we have x is equal to, over here we're squaring this whole thing. So the top 9 squared is 81 over 2 squared is 4. So x is equal to 81 over 4. Now, we need to check it. So we're going to plug this back in here. So 2 times the square root of 81 over 4 minus 9 is equal to 0. So we just need to play around with this sign. We're not moving anything over. We got to show that it's equal to 0. So if you remember from our rules here, we can rewrite this as 2 times the square root of 81 over the square root of 4 minus 9. This is 2 times the square root of 81 is 9 over the square root of 4 is 2 minus 9. We're just bringing the 0 down because it's got to be equal to 0. These 2's cancel each other, leaving me with 9 minus 9. And that's 0 equal to 0, so that's actually a solution. So that is not extraneous. So as long as you show this, you show me that it works, and we're good. All right, next one. Let's see. About number 6. So 6 is the square root of 5x plus 5 is equal to 0. So, got to undo what's being done to it in reverse order. So I'm going to subtract the 5 first on both sides. So square root of 5x is equal to negative 5. Excuse me, you square both sides. So I'm squaring everything. So that the square root and the square cancel each other, leaving me with 5x on this side is equal to negative 5 squared is 25. Now I divide by 5. So x is equal to 25 divided by 5 is 5. So x is equal to 5. Okay, but I need to check it. Okay, and back in like chapter 7 and 8, checking was optional. Here, checking is not optional. It is part of the problem. Okay, so check. So we're going to take this and plug it back in. So the square root of 5 times 5, and then outside is plus 5 is equal to 0. 5 times 5 is 25, so that's the square root of 25. Plus 5 is equal to 0. Square root of 25 is 5. Plus 5 is equal to 0. 10 is equal to 0. That is not true. Therefore, this is extraneous. or what the book says is that there's no real solution. Okay? So either saying it's extraneous or saying there's no real solution, either answer is fine. Okay, they both mean the same thing. Okay, but you still have to show me what the value was. You have to show that you checked it, show that it's not true, and then tell me that it's extraneous or there's no real solution. Okay? Let's see. Eight. Trying to give you guys as many examples as possible here. So the square root of x minus 8 minus 4 is equal to negative 2. So now this doesn't have a 0 on this side, which is fine. That really doesn't matter. So undo what's being done to it in reverse order. So first thing I need to do is add this 4 over. So the square root of x minus 8 is equal to negative 2 plus 4 is positive 2, okay, or 4 minus 2 is 2. Now I need to square both sides. Square and the square root cancel, leaving with x minus 8 over here is equal to 2 squared is 4. Need to add 8. X is equal to 12. Now I need to come over and check it. So we're checking it. Here we're plugging in 12. So we have the square root of 12 minus 8 minus 4 is equal to negative 2. 12 minus 8 is 4, so that's the square root of 4. Minus 4 is equal to negative 2. Square root of 4 is 2. Minus 4 is equal to negative 2. 2 minus 4 is negative 2 is equal to negative 2. So we've checked that it works. That is a solution to the problem. Let's see. $12. It's a little different here, so 12, we have 5 square root of x minus 3 plus 4 is equal to 14. So undo what's being done to it in reverse order. So subtract 4. So 5 square root of x minus 3 is equal to 10. Divide by 5. Square root of x minus 3 is equal to 10 divided by 5 is 2. Square both sides. X minus 3 is equal to 2 squared is 4. Add 3. X is equal to 4 plus 3 is 7. And now I just need to check it. So plugging 7 in for x. 5 times the square root of 7 minus 3 plus 4 is equal to 14. 5 times the square root of 7 minus 3 is 4, plus 4 is equal to 14. Square root of 4 is 2, so 5 times 2 plus 4 is equal to 14. 5 times 2 is 10, plus 4 is equal to 14. 14 is equal to 14, so we're good. That is true. I'll try to focus this really quick here. It's kind of blurry. There we go. All right. Hopefully that's a little bit clearer for you now. All right. So now we're going to look at something like 14 because it's a little different. It follows the same process, but it is a little different. So 14. We have the square root of 3x minus 2 is equal to the square root of x. Well, now you're probably sitting there wondering, well, what do I do? Because I have an x on both sides and they're both in a square root. Well, that's a good question to ask. But if you remember back to the rule that we said at the beginning, okay, if both things are equal, then if you square both terms, they're still equal. So we're going to square both sides, which is just going to get rid of these square roots. So that's going to give us 3x minus 2 on this side is equal to x on this side. Now, for the sake of keeping our x's on the left and not being confusing, I'm going to subtract this x over. So 3x minus x is 2x minus 2 is equal to 0. Now, I still need to get x by itself, so I'm going to add this 2 over. So 2x is equal to 2. Divide by 2. X is equal to 1. But still have to check it. So I'm going to plug it in. So this is going to be the square root of 3 times 1 minus 2 is equal to the square root of 1. So now this is a case where we get this, so 3 times 1 is 3, so it's going to be the square root of 3 minus 2 is equal to the square root of 1. So this now, 3 minus 2 is the square root of 1 is equal to the square root of 1, and we're good. Okay, so you don't end up with just numbers. Now, obviously, this is just 1 is equal to 1 because the square root of 1 is 1. But this is showing that it's equal because we can't mess with one side. We can only mess with one side. We can't do anything to both. Let's see. Let's look at 16 and then we'll look at 18. And we'll be done. 16 is the square root of 3x plus 8 is equal to the square root of x plus 4. So, just like this one up here, just like this one, okay, we have a square root on both sides. I have an x in both, so I have to square both sides. So now, the squares and the square roots cancel, so I get 3x plus 8 is equal to x plus 4. I want to get all my x's on the left, so I'm going to subtract x from over here. So 3x minus x is 2x plus 8 is equal to 4. Now I'm going to subtract 8. 2x is equal to 4 minus 8 is negative 4. Divide by 2. X is equal to negative 4 divided by 2 is negative 2. But I want to check it. So, I'm plugging negative 2 in for x. So the square root of 3 times negative 2 plus 8 is equal to the square root of negative 2 plus 4. So here, 3 times negative 2 is negative 6 plus 8 is equal to negative 2 plus 4 is positive 2. Negative 6 plus 8 is positive 2, so the square root of 2 is equal to the square root of 2, and we're good. So you'll see most of these do end up actually working out, but there are a few that are extraneous, so that's why you do have to check and verify. Alright, and lastly, and I'll give you your homework, number 18, square root of 21 minus x minus square root of 1 minus x is equal to 0. Now, you may be looking at this and wondering, well, what do I do with this one? Okay. Now, I can't, by the rules that we talked about yesterday at the very end of 11.2, okay, I can't do anything here with these two radicals. But if I move this whole piece over to this side, I now can. So I'm going to add the square root of 1 minus x to both sides. So on the left, I have the square root of 21 minus x is equal to the square root of 1 minus x. Now we have, just like what we had up here, where I have a radical on both sides, so I can square both sides. So I am left with 21 minus x is equal to 1 minus x. Now I want to get my x's on one side, so I'm going to add this x over here. So that gives me 21 plus 0, because negative x plus x is 0, is equal to 1, and that's gone away on that side. So now all of a sudden I have 21 is equal to 1, which I think you know is not true. I have no x's left. So that's not true. We don't even have to check it. We can immediately say no real solution. Okay, and that's all you have to do for that one. So remember, if you have any questions, feel free to let me know. Put a question mark by the number when you do it or something, and I'll try to work it out and help you. It's easiest if you tell me that you have a question, but I will try to check when I look at your homework and stuff to do that. So your homework for this section is 3 through 19 odd. And I'm going to look through the worksheets and decide what of the worksheets we're going to do. I'm not sure if we're doing all of them. I don't remember exactly what they all are right off the top of my head. So, but hopefully this will get you going. Hopefully this will help you understand a little bit better initially, and then we can go from there. So have a great day.